Right. Good morning or afternoon, whatever the case may be. For those of you that can't be here to watch this video, I'm sorry, and I apologize for what's happening to you this afternoon. But what's happening is the test, because I missed class last Thursday, we're going to put the test off till this Friday. I'm thinking the due date for this test is going to be Friday at noon. It'll open up Thursday morning at 8 a.m. and we can talk about that some more on Thursday if we need to. Okay? Now, last Tuesday we talked about properties logarithms, and we have most all the properties logs listed on this board over here. We're going to refer to it every once in a while. Number 1, log base b of 1 is equal to 0. Number 2, log base b of b is equal to 1. Number 3, log base b of b to the x is equal to x, and so on. Okay? Now, today we're going to talk about problems out of 7.4 and 7.5. And for my people in the evening classes, these problems, this handout is on Blackboard. Okay? So, let's start off with 7.4, number 1. It is e to the 4th minus, e to the 9th minus 4 natural log of x plus natural log of y. Now, to handle this problem, what we need to do is first make this part of this into a single logarithm. So we're going to talk about negative 4 natural log of x plus natural log of y. We're going to make that into a single logarithm. Okay? If you remember, logarithms have several properties, one of which we can make addition into multiplication with argument, yes? So I'm going to think of this as the natural log of y minus the natural log of x to the 4th. And all I did right there is I swapped the order a little bit. I brought this 4 up on top because that's one of the things about logarithms. They can bring exponents down to the equation where you work with them, and you can reverse that process. Are y'all with me here? Okay? Now, to write this as a single logarithm means the word natural log or log only appears once. Y goes on top because it's positive. X to the 4th goes downstairs because it's negative. Y'all with me? Okay? So, coming back to this problem, we can say this is e to the 9th plus the natural log of y over x to the 4th. Okay? Now, to simplify this, we can use the laws of exponents and think of this as e to the 9th times e to the natural log of y over x to the 4th. Okay? That's kind of running the laws of exponents in reverse of what we've seen before, but it does work. Go with me here. Okay? Now, remember, e, or the base, with a logarithm, whatever the base happens to be, b to the log base b of some argument is just some argument. So this turns into e to the 9th times y over x to the 4th. Okay? And that's going to be our final answer. Go with me here. Alright? Now, the second one, we have 2 times the log, and this is just common log, the log base 10, x cubed y to the 5th plus 4 logs of 1 over x minus 5 logs of y. Now, we're going to work this problem 2 different ways because I want to show you both ways and some nice properties. But no matter which way we work it, the first thing I'm going to do is get rid of this 1 over x here. I don't like that. Okay? Now 1 over x is what? X to the negative 1. And so we can think of this as minus 4 times the log of x. Okay? And if I bring this 2 up here, that's going to give me the log of x cubed y to the 5th squared minus 5 logs of y. Okay? Now, this turns into log of x to the 6th, y to the 10th. Because 3 times 2 gives you 6, 5 times 2 gives you 10. Bringing these numbers up, back up into the exponent, we get minus the log x to the 4th minus log y to the 5th. Okay? Now, our main purpose here is to write this as a single logarithm. Yes? Go with me here. Okay? Now, the word log should only appear once in our final answer. X to the 6th, y to the 10th goes on top because those quantities are positive. That's a positive coefficient. X to the 4th goes downstairs because it's negative. Y to the 5th goes downstairs also because it's negative. Okay? And then you just simplify the argument. This gives you the log of 6 minus 4 is 2. 10 minus 5 is 5. Okay? That's our final answer there. Alright? Now, another way I want to come back to this problem. We're going to write the log of x to the 6th, y to the 10th, minus 4 logs of x minus 5 logs of y. Okay? We're going to do the same problem. This is the same problem we had here. Okay? But we're going to do it a slightly different way, using some different properties. First, I want to split these two guys up. I want to write this as the log of x to the 6th plus the log of y to the 10th minus 4 logs of x minus 5 log y. Now, one of the properties of logarithms says you can bring exponents down into the equation where you can work with them. So this is 6 times the log of x plus 10 times the log of y minus 4 logs of x minus 5 logs of y. Okay? You with me? Now we have some like terms that we can combine. If you stop and think about it, 6 logs of x, negative 4 logs of x, those terms are alike, aren't they? What makes them alike is, number 1, the logarithm has the same base. Number 2, the logarithm has the same argument. Yes? This is like 6a minus 4a. So this turns into 2a, or 2 logs of x. We can do the same thing with 10 logs of y and negative 5 logs of y. Those terms are like also, aren't they? Log of y is exactly the same. 10 minus 5 is 5. Okay? And then you can take the exponents back up. This gives you the log of x squared plus the log of y to the 5th. And writing that as a single logarithm, you get the log of x squared y to the 5th. Okay? Tomato, tomato. You with me? But I wanted to show you both ways because at times you're going to need to be able to add and subtract logarithmic expressions. At times you're going to need to be able to do this. Okay? As far as writing them as a single logarithm, pick whichever way you like and run with it. Alright? Okay, now one property I haven't talked about is the change of base rule. And because of the camera, instead of walking all the way over that other board, I'm just going to rewrite the change of base rule. Logarithms can have as many bases as there are positive numbers, and that's a whole boatload. Yes? So, you're calculating those two bases, and there's going to be times when you need decimal approximations of different bases than e and 10. Okay? So, the change of base rule and this is one we didn't talk about last week. If you have the log base b of some number x, and you want a different base, generally you want the common log or natural log because those are the two your calculator knows. You can write this as the log base a of x divided by the log base a of the number b, of your base b, okay? That's your change of base rule, all right? And that's how we're going to handle problem number 3. Problem number 3 says log base 1/7 of 0.051, and we need a decimal approximation for that. Now, folks, if this is a 5-point test problem, you need to make sure you show me the right numbers and right formula for 4 of those points, okay? So, your all-important crucial step here, and it doesn't matter if you use natural log or common log, but you want to use one of those two. Generally we use common log. I would write this as the log of 0.051 over the log of 1/7. Okay? Go with me? 4 of your test points are in that step right there. Okay, if this is a 5-point test problem, there's 4 points. Alright? Now, you need to get the right number also to get your 5th and final point. And when you punch this into the calculator, it's really pretty simple, but you have to watch parentheses. When you punch log or natural log, it automatically opens the parentheses up for you. Yes? So when you punch this in, make sure you close that parentheses right there. Alright? If we get a decimal approximation for this, I'm going to take the log of 0.051, close the parentheses, divided by the log of 1 divided 7, and round into 2 decimal places, comes out to be 1.53. Okay? And y'all should punch that in on the calculator, make sure you get the same number I'm getting. Alright? Okay? Go with me? Alright, now, next problem, number 4. We have part A, the log base 2 of 4 times x squared plus 16x plus 16. Now, if you remember last week, we talked about using properties of logs for stuff like this. You can split up multiplication, you can split up division. We also made a special deal, the bottom of that list over there, that you cannot split up addition or subtraction. Yes? And when you look at this argument, it's all an addition or subtraction, isn't it? So you ought to be thinking, can you factor it? And if you look at this, it will factor, won't it? We can pull out a common factor of 4. We have the log base 2 of 4 times x squared plus 4x plus 4. Okay, go with me? And now the 4 and the x squared plus 4x plus 4, those are 2 factors. And I can split that up. I can write this as the log base 2 of 4 plus the log base 2 of x squared plus 4x plus 4. Okay? Now, this example is somewhat unfortunate because I've got way too many 2's going on. So I'm going to use a different color. I hope it's going to show up on film. Log base 2 of 4. Well, 4 is what? 2 to the second, isn't it? So I'm thinking of this as the log base 2 of 2 to the second power plus the log base 2. Now, x squared plus 4x plus 4 factors also, doesn't it? It factors into x plus 2 twice squared. Yes? Now, simplifying that, the log base 2 of 2 to some power is simply some power. Yes? So, the first term here turns into 2. Okay? And then this, you can write this as 2 times log base 2 of x plus 2. all right? Now, when you're doing your homework tonight, they're going to have boxes in the software for you to fill in, okay? You're not going to have those boxes on exams and quizzes. You're going to have to know what to do with these. All right, go with me? All right, now, the second part B of this, I put it in here because it tends to confuse students when they first see it. That's 10,000 to the 25x. And they're really not that bad. What you need to do is first start from the innermost and work your way out. Okay? Now, log, what's the base?
10.
10. Okay? So we have log base 10 of 10 to some power, don't we? First thing I want to do is simplify this some power. So, I have the log of 10, 10,000, I've got 1, 2, 3, 4 zeros, is 10 to the 4th, that's raised to the 25x. Yes? Now, the exponents like that, we multiply them. So this gives us the log of 10 to the 100x. And once again, if you have the log base b of b to some power, that's simply some power, isn't it? So this inner part here, the log of 10 to the 100x, is simply 100x, isn't it? So what we get is the log of 100x. Go with me there. Okay? Now, 100 times x, we can split that up. This gives us the log of 100 plus the log of x. And hopefully you recognize the log of 100 as being part where y'all say 2. 100 is what? 10 to the second, yes? So this is 2 plus log x. That's our final answer. Okay? Alright, so guys, that's the problems I want to show you out of 7-4. Alright? Good luck. Go do some math.